The name of this lesson is Ratios and Proportions with Applications. So a ratio is just a comparison of two numbers using division. You can see the fraction 2 over 3. That is a ratio of 2 to 3. A lot of times it's written, mostly it's written as just a fraction. Also sometimes you'll see 2 to 3 written like that with colons. A proportion then are two ratios that are equal. And this is an important rule in math, because if two ratios are equal, their cross products will always be equal. So if A over B is equal to C over D, then you cross multiply and you get A times D is equal to C times B. So for example, we know that 1/2 and 2/4 are equivalent fractions. So if we set this up as a proportion, we set them equal, and we would cross multiply, and we would say 1 times 4 is equal to 2 times 2. So that is what we mean by their cross products are equal. And we can use this rule in math to solve a lot of equations. Okay, so let's look at our first examples. Our first examples are just asking us, would these two fractions form a proportion? So all you need to do is just cross multiply and see if their cross products are equal. So 16 times 4 is, let me double check, is it 64? 16 times 4, yeah, is 64. And is that equal to 6 times 12? 72. No, they are not equal, so those would not form a proportion. So you just look at the quick check and you cross multiply, and 3 times 10 is 30. And is that equal to 5 times 6? Yes, those are equal, so those form proportions. The box is just reminding us that if you have a fraction that's negative, when you cross multiply, you can put the negative in either the numerator or the denominator. It doesn't matter which one, but certainly you can't put them in both. So let's look at a couple more examples here. We have an example and we have a negative. So again, put the negative wherever you want. I'll put negative 3 over a positive 7 is equal to x over 14. And then we just cross multiply. And you get negative 3 times 14 is negative 42 is equal to 7x. And then you divide both sides. And you get x is equal to negative 6. Please pause and do the quick check. Okay, I put the negative in the top. It doesn't matter where. And then when you cross multiply, you get negative 120 is equal to 8x. And then you divide both sides by 8. And you get x is equal to negative 15. Okay, so a little bit of algebra to solve the problems. Now this next box, what this is telling us is that according to the distributive law, parentheses are needed when numerator or denominators contain polynomials. And then make sure that if you are distributing through a parenthesis, you have to distribute the entire parentheses. So in example 3, you just have to make sure that you put x minus 9 in parentheses. And then it's the same. We're going to cross multiply. 4 times x minus 9 is equal to 16 times x. And then you just have to be sure and distribute. So we get 4x minus 36 is equal to 16x. And then it's just an algebra problem from here. You get negative 36 is equal to 12x. Divide both sides by 12. And x is equal to negative 3. Okay. Please again pause and try and do the quick check yourself. And remember, x plus 6 goes in parentheses. Okay? Hopefully you did this, but we'll get 3x plus 18 is equal to 5x. And if you subtract 3x from both sides, you get 2x is equal to 18, so x is equal to 9. So let's a couple more. Here, the difference is that we have quantities on both sides, but it's the same rule. You're just going to make sure you use parentheses for both. And so it's going to be 4 times x minus 2 is equal to 2 times x plus 6. And then, again, these are pretty basic algebra problems at this time. Subtract 2x from both sides and add 8 to both sides. You get x is equal to 10. Please pause and do part D. And you would have 8 times x minus 5 is equal to 7 times x plus 2. Get 8x minus 40 equals 7x plus 14. X is equal to 54. Okay, so now what we're going to do is we're going to look at some word problems, and we're going to be using the setting up proportions. Okay, I'm going to scroll a little bit here. Now, they give you this here is supposed to be helpful for you in trying to set it up, okay? So, proportion using only units. When we have, like, let's example 4, Sammy created a model fort. He used a scale of 1 inch to 2 feet. So we have inches to feet. Okay, and a lot of times the question comes up now, do we need to convert? Do they have to be the same? Okay, now here's the rule is you can set inches to feet equal to inches to feet. Okay, so you can have inches and feet or ounces and pounds, and you can have different dimensions, but you have to line up numerator and denominator with the same units. Okay, so if we read this, Sammy created a model fort. He used a scale of 1 inch to 2 feet. So that means I've got inch to feet. Okay, so when I set up the other side, it has to be inches to feet. The walls of his model were 9 inches tall. How tall were the walls of the actual fort? Now here's something else to think of. You need to decide where your x goes. So he created a model. His scale was 1 inch to 2 feet. So the 1 inch was the model. Okay, the actual is the 2 feet. So the walls of his model were 9 inches tall. So the model is in the numerator. So your 9 goes here and your x goes in the bottom. And so that shows your answer, x, is going to be in feet. So we have 1 over 2 is equal to 9 over x. And when we cross multiply, we get x is equal to 18. And so the answer is 18 feet. Okay, so you have to be careful with your dimensions, and you need to make sure whether you're putting the x on the top or the bottom of the ratio. Okay, so let's look at the next one. And an artist makes a scale model of a sculpture. Okay, so again, you're going to have a scale and you're going to have the actual. She uses a scale of 1 inch to 6 inches. Okay, so it's inches to inches. So we don't have to worry about dimensions. The actual sculpture will be 48 inches tall. So where does our x go and where does the 48 go? Okay, the actual sculpture is 48 inches tall. So this would have been, the 1 would have been the scale model, and this would be actual. So that means the 48 goes in the bottom. And now we cross multiply, and we get 48 is equal to 6x, and then you divide 48 divided by 6. I'm going to use my calculator to make sure I get it right, and it is 8. And so it is 8 inches. So her scale model height will be 8 inches. Okay. So now let's look at the next one. It takes 12 ounces of sugar to make 2 quarts of lemonade. Okay, so we have ounces here and quarts. At this rate, how many ounces of sugar does it take to make 3 gallons? So here we have ounces in the top, but on one we have quarts in the denominator, and the other ones we have gallons. So we do have to make a conversion here. It doesn't matter whether you want to convert quarts to gallons or gallons to quarts. I would go with the one that's easiest. And so you don't have to use a fraction. I think it would be better to convert gallons to quarts. Okay, so let's look at our proportion. 12 ounces of sugar to make 2 quarts of lemonade. At this rate, how many ounces of sugar, so the sugar's on the top, to make 3 gallons? Okay, there are 4 quarts are equal to 1 gallon. So we just take 3 gallons and multiply 3 times 4, and we get 12. And so now we're going to cross multiply. We get 144 is equal to 2x, and we divide by 2. And so it will take 72 ounces of sugar to make 3 gallons of lemonade. All right. So let's look at the next one. And please pause it and try and set the proportion up yourself first. Okay. So hopefully you did that, and it's 2.5 dozen muffins require 600 grams of flour. How many dozen muffins can be made with 900 grams? If you cross multiply, 900 times 2.5 is 2250 is equal to 600x. And then you divide, and you get 3.75, and this is dozen. So you can make 3.75 dozen cookies, muffins. Okay, so let's look at the next one. I think we get something a little different here. This one you need to think about a little bit. The El Paso City Council considers whether to implement curfew laws for minors. The ratio of people who oppose the implementation of curfew laws to those who support is 4 to 9. So we have 4 oppose to 9 that support. Okay. But if 312 El Pasoans are surveyed, how many do you expect to oppose? So we have to think about this. This is a little bit different because that 312 number, that doesn't actually relate to the oppose or support. That is like a total number of people that are surveyed. So sometimes your proportion, you might need a total. So what you can do is 4 oppose to 9 support, and so the total of that is 13. So now when you go to set up your proportion, we can use how many do you expect to oppose. So we want to know how many oppose. So we're going to take the 4 over a total of 13 is equal to x over a total of 312. Then you're going to cross multiply, and you get 312 times 4 is 1248 is equal to 13x. And then we just divide by 13. And you get 96. Okay, now a good way to check your answer here, if this is a little bit different. So if 96 oppose, how many would support? Well, a couple different ways to do this, but one, if there were a total of 312 that were surveyed, if we just took 312 and subtracted 96, we would get 216. So why don't we set up another proportion and check our answer and make sure we get 216?